Soil solution and plant nutrition. In general, the concentration of nutrient in the soil solution is low and not enough to the plant to complete its life cycle. For this reason, farmers usually add fertilizers, chemical fertilizer or organic fertilizers. The soluble amount of element in the soil does not represent in the total amount of element in the soil, but represents the available amount of the element to be absorbed by a plant, because there is some element do not dissolve in water, but it's present in the solid phase. Replenishment of plant absorbed element from the element solid phase. So the solid phase, the element in solid phase released to the soil solution usually when its concentration decreases. There is many factors affecting the availability of nutrients in the soil. Factor affecting nutrient availability in soil. Two terms should be taken in your consideration with respect to the concentration of nutrient on the soil. The first is intensity factor, which means that the actual concentration of nutrient in the soil solution. Capacity factor, it means the ability of the soil or the ability of the solid phase in the soil to compensate the low concentration of an element in the soil solution. So sandy soil, its capacity factor is low, while the clay soil has a high capacity factor. As a result of the plant absorption of element, their concentration in the root contacting area decrease. Diffusion of ion occurs from the higher concentration toward the plant root. Many factors affect the nutrient solubility in the soil. The most important one is the pH. Most of elements dissolve in a low pH. When the pH decrease, most of the elements became soluble. Reduction and oxidation condition also affect in its solubility due to its effect on soil pH also. When soil is flooded with water, anaerobic conditions arise, and most reactions in the soil are reduction reaction. Reduction reaction are proton depleting reaction, and subsequently a decrease in hydrogen ion occur on the soil pH increase accordingly. The soil aeration and predominance of oxidation condition led to the release of proton, which reduce the soil pH value and subsequently increase the soil acidity. The solubility of elements is affected by changes in oxidation and reduction condition due to their effect on soil pH. So these are the two important factors affecting the soil nutrient solubility and availability in soil. Chemical properties of soil colloids. Electric double layer adsorption, cation exchange capacity, cation exchange, anion exchange, soil pH, and soil buffering capacity. Actually, you can say that these are the interaction between the liquid and solid phase. We have a concept called electric double layer. What double layer? يعني two layer. It's mean two layer. There are many many positive and negative ions on surface of or close to the surface of the solid phase, while others are free and able to exchange with other cations. Negative charge on the soil surface are electrically equivalent to positive ion or counter ion. Both negative and positive counter ion charge from the electric double layer form the electric double layer. The first layer represents the negative charge on the soil. What we meant by electric double layer? That you have two layers. The first two opposite layers. The first layer represents the negative charge on the soil surface. The second layer represents the counter ion presented in the liquid adjacent to the soil surface. So you have two layers, positive and negative. Negative on the solid phase, positive to equivalent the negative charge and contain a positive charge. The positive charge present in the soil solution could be attracted to the soil surface or diffuse in the soil solution surrounding the soil surface. We have three theories describing the double layer, these double layers. The first theory is a Helmholtz double layer theory. Helmholtz assumes that a double layer consists of two layers, a negative layer on metal, soil metal. Imagine that it is a soil particle, but it's a small pieces of soil particle. If you complete the circle, so then you have a circle of soil particle. But we take only a small pieces of the particle, and it looks like a line. If you have a negative charge here on the metal, and there is Helmholtz assumes that a negative charge on the surface of the soil and distributed homogeneously on the surface. The second layer is a counter ion and has a position in a level parallel to the surface and away from it at a certain distance. So the Helmholtz theory concluded that there is two layers, a negative on the metal, and after a certain distance there is a positive charge to equilibrate the negative charge. This is a Helmholtz layer. The second layer is Gouy-Chapman double layer theory. Gouy-Chapman double layer has some assumption. The first is the negative charge is evenly distributed on the soil surface. The concentration of cation on the soil surface is very high and decrease. So the concentration is very high near to the surface and decreases as they move away from the surface. So Helmholtz two layer only, but here there is a negative charge, a high concentration, and the concentration decrease away from the soil surface. Therefore, it's called the diffused double layer. Look here, Helmholtz have a negative charge and positive charge. Chapman, there is a negative charge and a high concentration decreasing away from the soil surface. The assumption of Chapman's theory. The colloidal of he has some assumption for his theory. The first is the colloidal of the soil surface is planar and extended to infinite. Infinite means that there is no effect on the particle's edge or corners, and this is not correct because the edges has an effect. Negative charge, the second assumption is the negative charge is distributed uniformly on the surface. Also, the negative charge is not distributed uniformly on the surface of the particle. The counter, because the particle is not like a ball, it has no definite, no a certain shape. Maybe platey, maybe like a ball, maybe there is, as you studied in biology, there is a different structure, the shape of the soil particle. The counter ion as a point charge and do not occupy any volume, and this is not correct because each ion has a volume and occupy a volume on the surface of the solid phase. The third is the concentration of point charge reaches as high as possible at the contact surface between liquid and solid phase. Joy and Chapman theory has some objection. For this reason, Stern theory is found. The third is Stern double layer theory. The Stern combined Helmholtz and Joy and Chapman theory. In this theory, he assumes that the radius and volume of counter ion are considered. The shortest distance between the ion and the soil surface is determined by the radius of ion. The effect of the ion volume is high, as close as possible to the soil surface. The diffuse double layer are divided into two layers in Stern. The first one is the same layer of the previous theory. We have double layer. The first one is a negative charge on the solid phase. This is the first layer, as I told you. So the first one is the same layer of the previous theory, like Helmholtz and Doi and Chapman theory. The two theory, all theory said that the first layer is a negative charge on the solid. No doubt on this, and no problem and no difference between each theory for the first layer. All problems are on the second layer. The second layer are on Stern are subdivided into two layers. Layer very close to the surface and contain more cation, and concentration of cation are maximum. It's called Stern layer, like Helmholtz layer. The second layer is a diffused layer in which the charge will reduce with the distance from the Stern layer and distributed as a Joy-Chapman theory. As I told you, Stern theory take in his consideration both Helmholtz and Joy-Chapman theory. This Stern, there is a Stern layer and diffused layer.